Anna. Today we're gonna work on the question merge sorted array. It's an easy level array question. The question states you're given two integers array nums1 and nums2 sorted in non-decreasing order, and two integers m and n representing the number of elements in nums1 and nums2 respectively. Merge nums1 and nums2 into a single array sorted in non-decreasing order, basically from small to large. The final sort array should not be returned by the function, but instead be stored inside the array nums1. To accommodate this, nums1 has a length of m plus n, where the first m elements denote the elements that should be merged. The last n elements are set to 0 and should be ignored. Nums2 has a length of n. And let's look at example 1. Nums1 equals 1, 2, 3. And the first m elements are what's in nums1, and then the next three is m plus n. So these three zeros are the space for the n. And nums2 equals 2, 5, 6, and the length of 3. And the output is 1, 2, 2, 3, and then 5, 6. So it's sorted in the correct order from small to large. The arrays we're merging are 1, 2, 3, and 2, 5, 6, and the result of the merge is 1, 2, 2, 3, 5, 6, with the underlying elements coming from nums1. So for this type of question, I think a lot of the brute force way would just be nums1 extend nums2 and then sort nums1 in place. But that time complexity, because Python sort use temp sort and it will be automatically n log n, it will be greater than using pointers. So for this type of question, I'm going to solve it using two pointers. So let's say pointer 1 equals 0 and pointer 2 equals 0. And then we can take out the nums1, because nums1 currently has 1, 2, 3, and then 3 zeros at the end. We want to take out the part of just 1, 2, 3. So we can do a nums1 lookup, where we just have nums1 content inside up to m. So up to m equals 3 is where nums1 ends. The rest would be 0. And then we can do a loop for I in range of m plus n, so the length of nums1 and nums2. We can compare if we can have statements. So if let's say nums1, we'll use the lookup because nums1 also contains 0. So nums1 lookup p1 is smaller than nums2 p2, then we can do we can modify nums1 in place. So the original nums1, I equals nums 1 lookup p1, and then we can increase the p1 by 1 in here. Also, this shouldn't be the only thing we're checking. We should also check if p1 is within bounds. So p1 is smaller than m, and nums1 lookup p1 is smaller than nums2 p2. And there's another case. Not only we're checking if p1 is within bound, and nums1 pointer is smaller than nums2 pointer. The other thing we need to check for is if p2 is already exhausted. If it's already exhausted, then we automatically append all of the rest of the numbers from p1. So if P2 is greater or equal to n, or P1 is smaller than, is within bound, and then it's also smaller than P2. So this means if the second nums2 list is already exhausted. And let's do the other. Otherwise, we would do nums1 I equals nums2 P2, and then we can increase the P2 counter by 1. I think that's it. Just modify in place. Nums1. Yeah, so this is how I would solve this question. Please let me know if you have any questions. And thank you so much for watching.